Hello everyone, welcome to another Python video. Today we're starting our series on working with object-oriented programming with Python. Here we're just going to be looking at some main, I would say, fundamental skills related to object-oriented programmings, and we're going to try to create our own dogs and cats classes and create instances of them and just see how they interact in a Python code. So let's start off. We're going to use the keyword called class. That's how you start to create your own classes and your own objects in Python. And since we're creating dogs, we're going to be creating a class called dog. Um, so the main thing about an object-oriented programming is that we have attributes and methods. So for a dog, it can have attributes like what the dog name is, what the breed, maybe their fur color and well done, and maybe their age. So we can code that in right now. So we can set attributes in a initialization method. And what we're going to do, we're going to be overriding the built-in initialization base method that exists in Python. So we're going to go with def double underscore init. Self has to be passed so that every method that we create within our class has a way to reference the attributes within the class and has a way to reference the methods that we built for it as well. So therefore, it's a keyword that exists in Python where we can use this word argument called self to reference attributes and methods that belong to the class that we're working in. Let's say that our dogs have a name, our dogs have a breed type, and let's say they have an age, like so. All right. And then what we can say is that these are the required arguments when we do initialize a dog. So what we can say is that end of class dog. We can say that dog1 is equal to a dog object that is named Marshall, as it's a breed of Westie. And then we can say that they are 3 years old at the moment. So we can need to have these arguments stated in the initialization method to be provided when we do create an instance of our dog. So this is an instance of our dog class. So dog1 is a dog object. All right, so we can say that now we have an attribute called name. It's going to be assigned to name. We can see that it has an attribute called breed. It's set to breed. And lastly, it has an attribute called age, and it's going to be set to age. All right. So these right side values, where we're saying we have these attributes, are coming from our method arguments, and then we're saying that self.name, self.breed, self.age, we are storing these name attributes within itself so that all dog objects will have these I would say will have these attributes associated with them. Okay, so if we make that and like this, then these attributes are accessible. So we can say that print f could say dog1 name is a dog1 breed. So if we were to execute this code with what we have written so far, it'll say that Marshall is a Westie, as in we were able to output the dog1's name attribute is a dog1 breed attribute, and we got to customize what those values would be. Awesome. Let's just create a method now. Okay. Just explanation, attributes are data associated with an object. And then we can say methods are actionable code / item that an object can execute. So we can do something very simple. We can say a dog can bark, and we can give it no arguments required, and we can say that it can just print it's a bark like that, and then so in our code when we're actually using our dog object, we can ask dog to bark like so. So now if we execute our code, we'll still output that us accessing attributes of dog1 is .name and dog1 breed and dog1 bark, and we can get it to actually bark like so. Alrighty. End of dog. Actually, no, we have that right there. Perfect. And then we can say that main portion of our code using our classes to create objects. So that's happening right there. Awesome. So we have a dog class and we can have a cat class. So okay, cat. We can say def init self name breed age, and it can go. We can actually just copy this over because we're going to use the same thing. And then we can say def meow self, and then we can ask the cats to meow like that. So we can say that we have cat1. We can call it anything really we wanted, but we can kind of cat. Let's say this is called Garfield. It's, I don't know, let's call it, it's a tabby and it's 10 years old. All right, we can say that this cat1 is cat1 breed, and we can ask cat1 to meow as well. If we if we execute our code, we're gonna see that Garfield is a tabby, and I guess it has meow. Okay, so dog1 is a dog object, and dog is an object from the dog class, and cat1 is a cat object from the cat class. All right, awesome. So we can add like interesting behaviors. Since we have created our own, basically our own custom data types, we can actually have it like have them interact as well. So let's say investigate. We'll let a dog investigate. We'll call it sniff. That's how dogs investigate, right? They sniff. So we can say self. And we can say object, and we can say if object name. Then we can say that we're gonna go print f self.name is curious about object name, like that. Else we can say print is not curious about object. Actually, we'll do the same behavior, but we'll say it's curious about object. All right, and now we can ask dog1 to sniff cat1 down here. All right, so we have a sniff method. And we gave that method to a dog. The cat does not have it. We can say that if based on this object that's been given, so we're going to provide an argument here. Self is ignored. Self is just given to every method, and it's like an ignored argument that we don't have to provide. It will be provided auto as long as we write the word self, and is required for every single method that you do write in a class. So we're going to sniff, and we're going to be given this an argument here. I just called it object, and I said if the object has a name, we're going to be doing something like this, and otherwise we're just going to print like the object itself. So let's execute our code, and it says here Marshall is curious about Garfield. Okay, perfect. So we have all these code running, but we're going to see some interesting behavior, and what we're going to do next is really make our classes printable. So I'm just going to ignore dog and make cat printable, because if I were to say print just cat1, just like how we can print out list strings and whatnot, it'll just output that in our main. We have a cat object at this memory location, because we really haven't coded a behavior to make a class printable, or any objects be printable that we have created. So we actually have to put that in. So the first thing, to make objects printable, we must override two base functions. Number one, and number two. Yeah, we need to override and just really just code in our custom features of how we want to handle this situation. This is for print and string situations, and this is for our custom object having a printable representation inside other objects. So it's nice to have this available as well. And then we have string. Sometimes you can just do the same output for both, but we're going to have a different feature in this one. So what we can do is to just have to say, just like how we did an override for the initialization method, we're going to override the string method and provide self. And we need to make sure that it returns a string. This needs to return a string to represent a string equivalent value when we try to print cat. So we can say we're doing an f string. We're going to be returning name. We can say self dot breed named blank. Okay. Like that. So now if I were to save this code, it'll say tabby named Garfield, right? We have like a tabby cat named Garfield, right? And so that's the string representation. So if I were to say random text is equal to the string of cat1 and print text, we'll get that tabby named Garfield. It will execute this code and return this and put that into our variable text right there. So that gives us a string representation of what our cat class should be behaving in that scenario. All right. And if we were to do .repr, so you can return something completely different. So we can say that we're going to return an f string of a cat object, or we can just call it cat. And then we can say name is self.name. Breed is self.breed, not bread. And then we can say age is self.age, like that. So, and then if we were to say print the repr of cat1 now, we will be able to output cat with the name Garfield, breed, and age values. So we got to customize how this object can be represented in other objects as well. And that's a codable feature. All right, so just to, as a complete overview, we created two very simple classes. One's called dog, one's called cat. They have very similar attributes, right? But we were able to learn how to create a simple method, a method that can interact with other objects if you really wanted it to. And we also learned how to use the string and representation overrides so that we can have it either make our classes have behavior when they're in a string scenario, or we can use the repr function to have a proper object representation when we do create your own classes. Okay, and this is going to be very important if you do decide to put your custom objects that you create from a custom class you made into other data types like a list or a set or even a tuple like that. So that gets very important when we have that kind of behavior and when you start to write your own custom code like so. Anyways, thank you for watching, and as always, stay classy.